Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about even and odd functions. Alright, so remember an even function, both tails end up in the same direction, and then with an odd function, one tail ends up and the other one goes in the opposite direction. So to check if a function is even, f of x has to equal f of negative x for all x values, so we'll just plug in a negative x instead of x and see if they're the same. And then an odd function, negative f of x, has to equal f of negative x. So we'll plug in a negative x for all the x's, and if everything is the opposite, then it's odd. Alright, so determine if the functions below are even, odd, or neither. So I have x to the fourth plus x to the third. So I'm going to replace the x's with negative x. So if I plug in a negative x to the fourth becomes x to the fourth, because a negative times a negative times negative times negative is back to a positive. Remember, for every two negatives you get a positive. And then plus negative x to the third, well, a negative x to the third, if I do it to the third power, if it's to an odd degree, it's going to stay negative. So that's going to become a minus x to the third. So this is not the same as f of x, because the one plus sign in the middle became a minus. And it's not, everything is not opposite, because x to the fourth is still a positive. So this would be neither even nor odd. The next one, I have x to the sixth plus 1. So if I replace the x with a negative x to the sixth becomes positive x to the sixth, and then the 1 stays a 1. So that is the exact same as the original. So that is an even function. 6x to the fifth minus x to the third. I'm going to replace the x's with negative x. Negative x to the fifth is still negative because it's to an odd power. And then when I multiply that by 6, I get negative 6x to the fifth. And then negative x to the third is negative x to the third. And when I have a minus a negative, it becomes a plus x to the third. So this is not the same as the original, but my 6 is now a negative, and my minus x to the third is now a plus x to the third. So all the signs change, so it's the exact opposite, which makes it odd. Alright, so special properties. Adding the sum of two even functions is even. The sum of two odd functions is odd. The sum of an even and odd function is neither even nor odd. And then when you multiply, the product of two even functions is even. The product of two odd functions is even. So if you're multiplying and it's all the same, they're both the same type, then you're going to get an even function. If one's even and one's odd, then it's going to be odd. And then even and odd, the only function that is even and odd is f of x equals 0. Alright, determine if the following are even, odd, or neither. So I have f of x equals x to the fourth plus x to the third. Okay, so to the fourth, that's even, and third is odd. So that's an even and an odd, so that's neither when I'm adding. Alright, the next one I have x to the fifth plus x to the third. 5 is odd and 3 is odd. So they're both odd, so when I add them, it's odd. X to the fourth plus x to the second. 4 and 2 are both even numbers, so when I add them, it's even. 6x to the fifth minus x to the third. 5 is odd and 3 is odd, so when I subtract, it's odd. 3x to the fourth minus 4x to the third. Well, one of the exponents is even and one of them is odd, so that's neither. And then same with the next one. I have x to the fourth and x to the third. One's even, one's odd, so that's neither. Then the next part, it says determine if the products will be even, odd, or neither. So they gave me three functions. F of x is x squared plus 1. That is an even function. G of x is x to the third minus 3x to the first. That is odd. And h of x is x to the fourth minus 4x squared. That's even. So if I do f of x times g of x, I'm doing an even times an odd. So if they're different when you multiply, it's going to be odd. And if they're the same when you multiply, it's going to be even. So that one's odd. F of x times h of x is an even times an even. Those are the same, so that's even. G of x times h of x is an odd times an even. Those are different, so that's odd. And f of x times g of x times h of x is an even times an odd times an even. So that would be odd. Alright, that's it.